Hey, thank you for staying on my YouTube channel to learn. Now we talk about the calculation of bijectivity of functions. How do you calculate how bijective a function is? How do you determine if a function is bijective? There are two things involved. First, such function should be one to one. That is, it should be one to one mapped, and that is injective. The function should be injective. And two, such function should be onto. And what does that mean? It should be surjective. Such function should be surjective. Once these two are carried out, then we say it is what? It is bijective. And we say the function is bijective. So the function is bijective. Quickly, let's get to work. Get to work. Let's solve questions 1 and 2. We solve the questions 1 and 2. What do we have? We are going to be having the first question that says, show. We have the function, when we have the region, a function of sort of r to r, so that f of x is equal to 3x plus 1, show that the function is bijective. If we are to show that the function is bijective, the first thing we show, like I said before, will be to show that the function is one to one, that is, the function is injective. And how do you show that the function is injective? One, to show you have the injective, you need to show that it is injective. So if you want to show that the function is injective, you need to show that f of a is equal to f of b. If you're able to show this, you have successfully shown that the function is injective. And from here, we can find f of a, and we can say 3a plus 1, that is our f of a, can be equal to 3b plus 1. So subtracting 1 from both sides, we are going to be having 3a plus 1 minus 1 to be equal to 3b plus 1 minus 1. That implies that 3a can be equal to what? 3b. Dividing both sides by 3, this cancel out this cancel out this. That implies that a is equal to b. And once a is equal to b, it shows that it is bijective. It is, we are showing for injectivity. It is injective. The function is injective. Now the next thing we show is subjectivity. The mapping should be onto, that is the function. You have to express it so that you find it, you determine, you say let y belong, or any other thing belong to the set of real numbers. And if that belongs to it, then the function can be equal to it. Yeah, because they are in the same domain. So we can have it this way. So I can say let let y belong to the set of real numbers. This means belong. It means y is an element of these real numbers. Then I can say 3x plus 1 is equal to y. Do you get that? So I can say 3x plus 1 is equal to 1. So by that, I can say, I can find, just like when you find the inverse of a function, I can try as much as possible to make x, this x, the subject of formula. So, which means I will have 3x can be equal to y minus 1, isn't it? Then I have from here dividing both sides by 3, then x can be equal to 1 over 3 open bracket y minus 1. Now the question you ask, this at the right hand side, will it belong to a set of real numbers? This will automatically belong to a set of real numbers. So if it belongs to a set of real numbers, it shows that this, because no matter the value of y you take, if you take y to be 0, take y to be 1, 2, minus 2, whatever, everything we get here will belong to a set of real numbers. This implies that what? It is what? It is subjective. So once it is subjective, we are good to go. Since it is subjective, it found it to be also what? Injective. That implies that the function, okay, I can say that implies that f of x is bijective, since it is both injective and subjective. Let's solve example 2. Let's check. You have to show that the function f of x exponential of x is what? Is bijective. That it should be injective. Checking for injectivity. Check if it's injective. We said f of a should be equal to f of b. So this implies that exponential of a should be equal to exponential of b. Isn't it? Take the natural log of both sides. I can say log exponential of a equal to log exponential of b. And this can be equal to a e equals to b. Okay, they have common base. You can put it here. Common base. Natural log. This gives you 1. This gives you 1. So a will be equal to b. It is injective. So since It is injective. So we have it to be injective. Then check for subjectivity. This subjective. Check it out. So we have subjectivity. Check if it is subjective. How do you confirm the subjectivity? You say let any other alphabet or any other element, let y for example belong to the set of real numbers. And what happens? That implies that exponential of x can be equal to y, isn't it? And if you have it this way, if you take the log, you have log of exponential of x and be equal to log of y. That means x, okay, is e, make this base e, be equals to log y is e. This becomes 1. X can be equals to log y, and you have base e. Now the question you ask yourself is, will this be bijective? So what do we have? You have your a log that because of b, so we can equally say from here you have x to be equal to log y. But log of negative numbers do not exist. Yes, if y is a negative value, what happens? Hence, I can write it here for you. Since log of negative numbers do not exist, so these numbers, log of negative values do not exist. So what does that mean? Let me finish up here. Since log of negative numbers do not exist, therefore f of x is not subjective, because y could be negative, then f of x is not bijective. Thank you for joining me on this also.